This is our final lesson over section 4.3, e-learning for February the 1st. So we're going to tie up loose ends with section 4.3. Because of last week, each of the classes got to different points. So if you've already seen something, you can scroll forward and get to what you haven't seen before. I'm going to start with what are called the cofunction identities. And the cofunction identities partner sine and cosine together, secant and cosecant, and tangent and cotangent. Now, it's not the same as the reciprocal identities because sine is partnered with cosecant and cosine with secant. Here, sine is partnered with cosine, and secant and cosecant are partnered. Tangent and cotangent are still partnered together here as they are with reciprocal relationships. So I want to first point out my triangle here, the diagram where you see the 30, 60, 90 triangle. This is the triangle we worked with the other day. And if I was asked to find the sine of 60 degrees, since I know that is opposite over hypotenuse, I could say that sine value is square root of 3 over 2. If I were asked to find the cosine of 30, I'm looking at the 30-degree angle, and it just so happens adjacent over hypotenuse, the adjacent side in our triangle to the 30-degree angle is also the square root of 3 over the hypotenuse 2. And what I want you to notice there is that the sine of one acute angle in my right triangle, probably should have had that there, the sine of one acute angle is actually equal to the cosine of the other acute angle. The other thing I want you to notice is the acute angles have to add up to 90. You may recall from geometry that the acute angles in a right triangle are complementary, meaning they add up to 90. So what we're finding is when I take the sine of the one acute angle, 60, the opposite side, which is the square root of 3, is the adjacent side for the other acute angle of 30. Which makes the sine of one acute angle equivalent to the cosine of the other acute angle. That's why up here, for the cofunctions, you see these two statements. The sine of an angle theta has to be equal to the cosine of 90 degrees minus theta. Since the two acute angles add up to 90, that's why we're taking 90 minus theta. Theta would be like 60, and 90 minus 60 would be 30. So this diagram confirms that relationship. And so now we can apply these cofunction identities to other problems. So let me erase all of this. And let's do these problems we see here on the left. And, well, actually, let me go with blue. So it says here the sine of 72 degrees. Well, the sine is a cofunction with the cosine. So it means that the sine of 72 has to be equivalent to the cosine of 90 degrees minus 72 degrees, which is really, the cosine of 18 degrees. So the sine of one acute angle equals the cosine of the other acute angle. How about the second one? Well, the cosecant is a cofunction with the secant. Here we're given it in radians, so I'm going to use radians, and I'm going to say the cosecant is equivalent to the secant of pi over 2, since that's 90 degrees in radians, minus pi over 3. You might say, well, can I convert it to degrees because I know pi over 3 is 60? Here you could, but in number 4, it's going to be a little harder. So I'm just going to show you with radians. Of course, I need here a common denominator, so I'm going to get that. That would be 6, which means it would be 3 pi over 6 and 2 pi over 6. So when I subtract, that means the secant of 1 pi over 6, and that makes sense because that would be 30 degrees, and pi over 3 was 60 degrees, so that confirms what we already know. Number 3, the cosine of 44 degrees. Since cosine is a cofunction with sine, we're going to say the cosine of 44 degrees would be equal to the sine of 90 degrees minus 44 degrees, and 90 minus 44 would be 46. So that would be 46 degrees. How about the final one, the cotangent of pi over 12? It will be a cofunction with tangent. And again, here we do want to use pi over 2 for 90 degrees in radians, minus pi over 12. This is where using a common denominator, which would be 12, this would be 6 pi over 12 minus pi over 12 means the cotangent of pi over 12 is equivalent to the tangent of 5 pi over 12. So hopefully that makes sense to you, and you just have to make sure you know which trig ratio is a cofunction with the given trig ratio. Pythagorean identities. I'm going to actually show you a problem here using both a cofunction and a Pythagorean identity. So we have 3 Pythagorean identities. You're not going to be asked to do a lot with this, but I do want to see that you understand how I can use them. So notice I have problem 47, which says the cosecant of 37 degrees times the secant of 53 degrees minus the tangent of 53 degrees times the cotangent of 37 degrees. It's an expression. They want us to simplify it. The first thing I notice is that cosecant and secant are cofunctions, as are tangent and cotangent. The second thing I notice is 37 plus 53 makes 90. So that means these functions are cofunctions and can be rewritten. The other thing I see is in the Pythagorean identities right up here, I have a couple Pythagorean identities that use tangent and secant or cotangent and cosecant. So I think what I'm going to do here is use both cofunctions and my Pythagorean identities to help me simplify this expression. So what I notice is cosecant and cotangent are in one Pythagorean identity. So I think I'm going to stick with cosecant and cotangent. So the cosecant of 37 degrees times the secant of 53 degrees. Well, since secant is a cofunction, I can rewrite secant as the cosecant of 90 degrees minus 53 degrees. And 90 minus 53 is 37, so that actually means I have the cosecant of 37 degrees times the cosecant of 37 degrees, which, if there are 2 of them, that is actually the square of the cosecant of 37 degrees, which we write as cosecant squared 37 degrees. I'm going to do the same thing, and I'm going to go with cotangent, and that's because in this identity up here, since I rewrote the first product as cosecant, I want to rewrite the second product as cotangent. So I'm going to rewrite the tangent of 53 degrees by using a cofunction and saying the cotangent of 90 degrees minus 53 degrees would be the cotangent of 37 degrees. And of course, that's being multiplied by the cotangent of 37 degrees. So I just rewrote this tangent as the cotangent of 90 minus 53 degrees, which means I really have cotangent of 37 degrees times the cotangent of 37 degrees. This can be written as cotangent squared 37 degrees. Now, you might be thinking, why did I do that? Well, take a look at what I'm going to be able to write. I'm going to take this first quantity. Let me change the color of my pen. This, and be able to replace it with this. So I am saying that cosecant 37 degrees times secant 53 degrees could be written as cosecant squared 37 degrees minus, and that's where I can take this and I can rewrite that as the cotangent squared 37 degrees. I just did a substitution. So why did I do that? Well, again, I'm going way back up here to my Pythagorean identity, which says 1 plus cotangent squared equals cosecant squared. So what I'm going to do here is I'm going to replace this. I'm going to say cosecant squared 37 degrees is 1 minus cotangent squared 37 degrees. And then I still have minus cotangent squared 37 degrees. Now, the beauty of this is I can have some cancellation happen, and cosecant squared 37 degrees minus cosecant squared 37 degrees can cancel out, and that all equals 1. I know that's a little confusing, but I wanted you to at least see how a cofunction identity and a Pythagorean identity can actually be used together. And it's just an interesting little thing to see. I'm not sure that I actually gave you anything like that in my math lab, but I thought you should at least see it. All right, the final thing, right triangle trigonometry with angles of elevation and depression. I have this handout. I gave it out in some classes and I've forgotten others, but it's right here. It's online, and I will give it to you in class if I missed your class. So what we have here are right triangle application problems where in the problem it might reference an angle of elevation or an angle of depression. Angles of elevation are where we sight upward. For instance, an observer sights from something up to something. So for instance, a person right here sights up to a plane. And you see the line of sight here. And the angle of elevation is formed with the horizontal here, and that's this 65-degree angle. Once you see that, you can use that to solve right triangle trig problems. And we'll do that here in a moment. Angles of depression actually are where someone, an observer, like someone in the plane, sights something below, like a person on a boat. Here is my line of sight, and the angle of depression is formed with the horizontal, And so that is my angle of depression, which is 40 degrees. Sometimes people make a mistake here because they want to draw perpendicularly down like this, and they want to make that angle right here, but that is incorrect. The angle, if you want to use alternate interior angles, you would actually be dealing with the angle like right here. So the 40-degree angle would be also 40 degrees down here. So you do have to be careful. It's not that angle. All right, so let's look at some problems. So I have in my first problem, and I've already drawn a right triangle, an observer in an air traffic control tower sighting an airplane at an angle of elevation of 32 degrees. I need to interpret that and understand in my triangle, that's where an observer is sighting up. So that angle of elevation of 32 degrees is right there. If the plane's altitude is 3.5 kilometers, that would put that right there. And so if they want to know the plane's horizontal distance, that would be that distance right there. Of course, that would be the tangent relationship because the hypotenuse is not involved, and we would write an equation like tangent of 32 degrees equals the opposite side of 3.5 over the adjacent side, which is x. And of course, we could write this as a proportion and solve it. And if you want to, you can. That makes that side be about 5.6 kilometers. But I did want you to see that setup. Number 2, on the other hand, says a Coast Guard rescue pilot sights a life raft in the ocean below. So that's where we're having an angle of depression. Since the angle of depression is formed with the horizontal, that means our 26-degree angle is right there. Again, sometimes people draw the wrong triangle and they want to draw down like this and draw their triangle like this. And they want to put that 26-degree angle here. That's incorrect. Now, could you put it down here? Yes, if you drew that triangle, because it would be an alternate interior angle with the angle of depression. But remember, the angle of depression is always formed with the line of sight and the horizontal, not the vertical. In this problem, it says the plane's altitude, let me get back in the black. The plane's altitude is 3 kilometers. What is the plane's distance from the raft? If they don't specifically say horizontal distance, they mean that direct line distance. So here the hypotenuse is involved and the 3 kilometers is the side opposite. So that would be the sine function. And we'd say the sine of 26 degrees is opposite 3 over adjacent, which is x. Again, we could put that as a proportion and solve. I am confident you should be able to do that. And that is about 6.8 kilometers. Last one. A kite is flying on 100 feet of string. Now, you got to understand that would be the 100 feet of string and makes an angle of 40 degrees with the ground. That's like an angle of elevation. So that's our diagram, and they want us to find how high the kite is flying above the ground. That would be that side. So now the hypotenuse is involved. It's the side opposite, so again, it is the sine. And the sine of our 40-degree angle is opposite x over hypotenuse 100. Make it a proportion, solve it. You should get about 64.3 feet. I hope that helps. What you are supposed to do is finish what you started in MyMathLab last week. There's only a little, and you do want to finish this for block day. We will be doing a pseudo worksheet quiz where you might be able to use your notes. So make sure they're in good shape, and we will go over questions and answers beforehand, and we'll get that completed. All right, hope you have a good e-learning day. Thank you.